keep you here too long. Thanks for staying. This is the very last talk. As I mentioned before, this is kind of a bit of a different angle. I'm more one of these cultural evolution experiments people. So what I'm going to present today is work from the Center of Language Evolution. These are my supervisors. And it's kind of a bit different from the usual talk that I mostly want to talk about a method that I want to present that I think is very interesting for studying language evolution. However, I'm going to talk a bit in the background about what I'm personally interested in, which is adaptation. And then I'm going to focus on lab experiments and their limitations and why I think VR particularly is interesting here and has a lot of potential. And I'm going to show some example projects that kind of outline this. So I want to start kind of with the question that keeps me up at night, besides the Lisbon airplanes that are really close to our Airbnb, which is why are languages structured the way they are, and why do they vary in the specific way that we see them vary among the languages of the world? And there have been some more recent developments in this area, particularly with regards to adaptation or external factors kind of influencing that. So some people now think that it's actually the social, physical, or technological environment that can actually influence structures. So language is not just kind of drifting around and changing randomly. There have been different things that have been proposed. I'm not going to go into all the details. There's a nice review paper by Lupien and Dale if you're interested in this. Basically, the idea is that some social variables like population size or even the specific climate can influence or like subtly bias languages to end up in different states. And one problem with this is that basically you could take any extra-linguistic variable and any linguistic variable and just kind of correlate them. And that seems to be, for some reason, something that particularly economists like to be doing. So there have been some of these kind of bit questionable papers coming out in recent years. And so this is, of course, a problem. You can't just take any external factor and link it to something in language. So how do we avoid these kind of spurious correlations? And people have recently argued in this field of kind of linguistic adaptation that really what you want to be doing is you want to draw the proper causal graphs. So rather than just linking, for example, ambient humidity to whether a language exhibits tones or not, which is something that has been proposed, really what you want to be doing is you want to draw the whole causal story and then identify which kind of sub-arrows in this causal story haven't been explained yet and then test them empirically. And in evolutionary linguistics, what we usually do is we either do Asian-based models, as you saw in Luc Steele's talk, or we do actually experiments with humans. So this is a recent one that you might have seen, for example, pop up. And among these experiments, there's two main types that people have usually done. There's the iterated learning ones that you might know from Edinburgh, where we model transmission. So these are kind of designed to model how language evolves when it's kind of squeezed through the cognitive bottleneck over cultural transmission, and people have identified things like specific learning biases and so on that seem to affect structure on this kind of trajectory. So for example, the emergence of compositionality was modeled in experiments like this. On the other hand, there are experimental semiotic studies, and these really simulate the emergence of communication in interaction. So you have participants interact in the lab, and they have to ground the communication system. And this can happen in different modalities. For example, drawing or gesture are frequently used, but also other modalities. And by now, there's all kinds of kind of versions of this, where also you combine interaction and transmission. You have micro-societies. If you saw Limor Raviv's talk yesterday, for example, it's a nice review paper on this. But one thing that these experiments all have in common is that it's extremely hard to get people to kind of isolate the specific variables that you're interested in. So usually people have to kind of come up with very unnatural tasks. So this is a classical study by Bruno Cantucci, where you really, if you want people to create a communication system from scratch, you already know language, you kind of have to put them in a really weird situation, in this case with abstract shapes and so on, and give them a weird way to communicate. And they have often been criticized for what psychologists call ecological validity, which is often kind of perceived at the other end of experimental control. So what we usually say is we have to sacrifice ecological validity because we want to have experimental control. So usually when people talk about ecological validity, high ecological validity, they mean things like conversation analysis and so on, where you have like really free tasks that provide the full richness of human communication or behavior. And then on the other hand, when you want to study a specific tiny phenomenon or mechanism, then you need lots of experimental control. So you want to have trials, you want to have like very distinct things that you test, and then you lose this ecological validity. What I want to suggest here is that these are actually, this is not my idea, this is from David Peters, but if you use specific methods like VR, you notice that these are actually orthogonal rather than at the end of the spectrum. You can actually try to get both. I'm going to suggest that immersive virtual reality is one of the ways of doing that. And that is because there's no artificial separation from the stimuli. You're basically in the stimulus. There's no limits and representing the whole, this richness, like in conversation analysis, you can have everything from eye gaze, gesture, multimodal communication. You can track all of that, so that gives you a lot of control, and you can also control everything that happens in the world that appears, and so on. There's some other advantages to VR as well. It's particularly useful to study, of course, phenomena that are either spatial or embodied, because you have participants that are embodied in the world. They can take perspectives, multimodal communication, things like that. And you can also use virtual agents instead of confederates, for example. Then another nice thing nowadays is we have a lot of headsets available, and because they are now on the consumer market, they are much cheaper and also much easier to program. So you can actually use scripting languages, and there's like game engines and things like that nowadays. And another advantage is because of the modern hardware that we have, we can actually take it to the field, and we can also use it to study cultures that normally don't interact with computers much, or also older people that normally don't interact with computer much, because they are much more intuitive in how you actually interact with the world. You can just touch things, manipulate them in a very kind of naive way. Just to show you some of the headsets, so in Edinburgh we bought the Vive in 2016, but depending on what you want to do, you can also get ones that have like crazy high resolution, or you can use mobile ones where you can just plug in a smartphone if you're on a budget or you want to go to the field and things like that. And there's also different kinds of controllers that allow you to interact with the world. So this one, for example, allows you to track all 5 fingers, and people are now increasingly develop these kind of gloves where you can actually represent hands in the VR as well, which is quite nice for if you want to study gesture, multimodal communications, things like that. This is for if you want to go cordless. I'm not going to mention that too much. I want to now talk about what you can actually use this in language evolution research. So one of the things that I'm interested in is spatial language and environment. And there it has often been discussed to what extent these two things could relate. So if we have a spatial scene like this, this was actually mentioned in one of the plenaries today. Different languages like to use a different frame of reference. In English, we like to say something like the ball is to the right of the car. In some other language, you might use a geocentric frame of reference and say something like the ball is downhill of the car. So rather than your egocentric perspective, you use properties of the environment. And there have been a lot of discussions about that, because some languages only use this second one. I can't go into much detail here, but basically what's been recently discussed a lot is like what determines why languages use one system over the other. And there has been a lot of field work. So for example, for Mesoamerican languages, they found that if they're spoken in different villages and they use the same kind of uphill-downhill distinction, where they actually use that distinction, for example, indoors, correlates to the topographic hills outside. So even though they use the very same lexicalized terms, it depends on where you live. But then there were also other factors like literacy and how much they use Spanish and so on that kind of influence that, and it's very hard to disentangle this. And this is another example on atoll languages. So atolls have basically this laguna and then the open ocean around. And on unrelated languages, you often find systems that make a distinction between towards the laguna versus towards the open sea. And what's interesting is that if you take, for example, a language spoken on an atoll, but then you go to an island that's not part of the atoll, they will use more egocentric, and also depending on whether they are fishing or not, whether they interact more with the ocean, they use different. So there's all these kind of topographic, social factors influencing that, but we don't really know the exact causal nature. So I think one thing that would be nice would be to do experiments on this. And traditionally, experiments in spatial language, they have often focused on like tabletop tasks, kind of spatial arrays. It's even in the titles of the papers. I say enough with the tables. Let's move to actually the large scale. And in a very simple first task that we did, we took just two environments, kind of a forest and a mountain that we designed. The forest kind of affords egocentric because there really, no matter where you are, everything kind of looks the same, but here you have this very nice geocentric affordance of up and downhill. And in this task, we just wanted to see will this make a difference to how people in their native language kind of solve spatial tasks. So we represented our participants with avatars in this world, and they had to play a spatial coordination game. So they were in one of these environments. One of them became the seeker and the other one the director, and then what they had to do is they had to collect these orbs to get points. Now the tricky thing is only the seeker can collect them, and they have this what I call area of visibility. That means that the seeker can actually not see the orb until he or she gets really close to the orb. And that's a bad strategy because they only have 2 minutes per round. That's where the director comes in. The director can see the orb from any distance. And now in natural language, you usually point there and just say, go over there. But the nice thing about VR is you can just disable that by making the director invisible to the seeker, but not vice versa. So they had to communicate in order to find the orb. And so the idea is they do this in one of these two environments, and they switch roles every round, and then after a while they should have some conventionalized strategy about how they talk about space in these environments through alignment and these kind of interactional processes. So the prediction here was that if spatial language is actually sensitive to environmental cues, maybe they use less egocentric on the slope and also use this uphill-downhill distinction, even though they could just as well use left and right, which is usually what English speakers like to do. So here's how it looks like in the forest.
Yeah, it's right next to Okay, if you turn up 180, and there's a big tree you can see, and go through that, and then beyond that again, and there's, 90 to your right, and let me get a little closer to you. Turn a little bit left, and then...
Okay, so you can kind of hear they use left, right, things like that. This is an example from the mountain. And by the way, it looks much more steep in VR when you're actually in there. It's really hard to represent this in video.
So, right. Yeah, that's right. Go forward about 3 times. Oh, I saw it. Yeah, you just go back once. I saw it somewhere. Back up, uphill once. All right.
Yeah, okay, so you could hear them use uphill, actually. So the task is not harder in any condition. The task performance is exactly the same. They collect the same number of orbs. But they do actually use more of these kind of allocentric uphill-downhill distinctions on the slope. We were then interested in this kind of ongoing work, whether maybe it's flexibility that really makes this left-right system in the wild often override the... oh, sorry, actually this is the wrong graph. I'm just going to skip this. This basically just shows that some participants still behaved like in the forest. So it is possible to use left-right. So these are the individual participants. Sorry, I forgot that. So in the second experiment, we wanted to test flexibility of this strategy. So maybe it is that left-right is a really, because it's often a strategy that kind of culturally overrides the geocentric one, the allocentric one. We thought maybe it's a good strategy because it's flexible. You can use it in both environments. So we were thinking of testing participants switching environments. And you then, of course, on the slope, they have to abandon their geocentric strategy. So you get this kind of flattening down here. But what we didn't find is that they would just keep using the egocentric strategy on the slope. And so we couldn't really support this flexibility hypothesis. And we think that that's because they're just using their language, a native language, which just can do both same things. So there's not really this conventionalization process. So now we're doing what I actually wanted to do in the first place, which is look at emergent communication. I just started with English because I got too excited once I had the VR up and running. But now we're actually having them communicate with symbols, and I'm interested in like what happens if there's a cost to negotiating strategies and stuff like that. We can talk more about this later. I just want to move on quickly. So this first kind of line of experiments shows that VR allows you to study spatial language on the large scale. There's maybe already some suggestion that the environment can affect spatial language. which could motivate these systems in the wild that are often based on these kind of salient landmarks and so on, but we couldn't support the hypothesis that left-right is more flexible than uphill-downhill. And follow-up experiments are basically addressing that, and also we have a lot of experiment in mind about mobility, changing environments, but also cultural transmission, contact, things like that. But I want to now talk about something completely different, which is strange worlds. And what I mean by that is, it sounds really crazy, but I think one thing that you can do with VR that wasn't possible before is you can probe the universality, the robustness and flexibility of language that evolves in the real world. And that is because you can actually test what happens if language evolves in an alternate reality, and that you can create environments, or if you want to learn how language interacts with the world, you can create environments that are not how language would usually evolve in the real world, where you can, for example, change how inherent specific properties of objects are, or you can even do stuff like circular time, weird spaces, or you can have participants in weird bodies or misaligned perspectives that you usually wouldn't get. And that can tell you something about how language, how flexible language actually is. So just to give you an example, because I think this makes much more sense if you actually look at an example, there's this idea that there's an isomorphism in the noun phrase, where usually most languages put the determiner furthest away from the noun, and then you have the numeral and the adjective, both pre- and post-nominal, and most languages do this. And there's some evidence that this is due to a cognitive bias. Now, what does that mean, to have a cognitive bias for that? We don't really know. So this is kind of an unsatisfactory answer, but of course this cognitive architecture could actually have been affected by how we interact with the world. So maybe it's something that is learned just through interacting with objects and how reliable certain properties are and things like that. So what we did is we started designing a task where you actually interact with weird objects in a weird world, and through interacting with these objects you also learn an artificial language, in this case a post-nominal noun and one modifier language. And we vary how reliable or inherent traits like number or distance are. And then we basically have participants produce two modifier labels. And the prediction is then that if we create a world that is strange, where distance is more reliable than number, then maybe we get the weird order that doesn't occur in natural languages. So that could be then a nice kind of support for this idea that it's the environment shaping that. So far we only ran a pilot on this, but I just want to mention it because we did this at the Edinburgh Science Festival, and that's another advantage of VR. It's really good for getting participants in public engagement, because people actually enjoy taking part in these experiments. So I just want to conclude by saying that VR is an exciting new paradigm for studying language evolution, and specifically adaptation, which is what I'm interested in. And that's because of naturalness. You have this high immersion and ecological validity, while at the same time having this very tight experimental control where you can manipulate exactly everything, like what's visible, what's being shared, what appears when. And it's also open-ended in the sense that if you can think of it, you can create it in VR. So you can even kind of learn about how language kind of evolves in these kind of possible worlds, which maybe might tell us something about what's special about the language in the real world. And lastly, it's fun. Might sound trivial, but it was really helpful for me that I could get participants quite fast to sign up for these studies. So we have the technology, we should use it. I'm providing some resources on if you want to create your own VR experiments, which I'll upload. Or alternatively, you can just hire me as a postdoc next year. Cheers. Thank you.